Good evening to all. So today we are going to start Euler's theorem based on homogeneous functions and total derivative, maximum minima, improper and evaluation of definite integrals, etc. Definition: if f of kx comma ky is equal to k power n into f of x comma y, then f of xy is said to be a homogeneous function in x and y of degree n. See, that is, each is of same degree, each term is of same degree. That expression is called homogeneous expression. Let us take two variable function. To say that two variable function is homogeneous function of some degree n, just replace x, y respectively by k into x, k into y. K is a constant, and then simplify. If you get like this, k power n, k raised to n into given function, this n is called degree and this function is called homogeneous. Okay, next, Euler's theorem, or someone pronounced as Euler's theorem. If u is a homogeneous function, Fn stands for function, in x and y of degree n, then statement 1 is x del u by del x plus y del u by del y is equal to n into u. Statement 2 is x square del square u by del x square plus 2xy del square u by del x del y plus y square del square u by del y square is equal to n into n minus 1 into u. So take any homogeneous function, find these derivatives and then consider LHS in both results, check this RHS is getting or not. That means this theorem helps a lot to, whenever it is homogeneous function without finding derivatives, we will get that result. That means it looks like in the form of first order derivatives. Now these are all second order derivatives with respect to x and y, whenever u is a function of x and y. Similarly, third derivative, it looks like binomial theorem, a plus b raised to 1, a plus b whole square, a square plus 2ab plus b square, just the coefficients like that, Pascal's triangle, a plus b whole cube. Now the same Euler's theorem is also true for whenever it is a homogeneous function in x, y, z, any number of independent variables. This result holds. Okay, note, if in some problems u is not a homogeneous function, u is not a homogeneous function in the given variables, but f of u is a homogeneous function in x and y of degree n, then the above first two results are written as, that means becomes x dou u by dou x, del u by del x, y del u by del y is equal to n into f of u divided by f dash u. So let us say g of u. Okay, say this quantity, the simplification of this value, I am taking g of u. Second order, x square del square u by del x square plus 2xy del square u by del x del y plus y square del square u by del y square is equal to g of u times g dash u minus 1. Just by heart this note point, that is Euler's theorem. Whenever it is a homogeneous function, the f of u is a homogeneous function, then these results with RHS a small change. Okay, these two results are modified as this one. Now I am giving an example, one each. That means the function is itself originally homogeneous. In another example, the function is not homogeneous. How to make homogeneous? Simply says that each term is of same degree, that is called homogeneous function of that degree. Okay. Example, this is given 2005, 2 marks. 1. If f is equal to a naught x power n plus a1 x power n minus 1 into y plus a2 x power n minus 2 into y square plus so on a n minus 1 x into y power n minus 1 plus a n into y power n, where ai's, that is all a naught, a1, a2, okay, are constants, comma, then x del f by del x plus y del f by del y is equal to say solution. Now from first term onwards, calculate the term degree of each term, whether it is same or not, then only it is called homogeneous. The degree of this x raised to n is n. This is in product, two variables, so add the powers, add the exponents. N minus 1 plus 1, total degree n. N minus 2 plus 2, degree is n. 1 plus n minus 1, degree n. This is n. So each is of same degree n. Okay, so I am writing directly, clearly, f is a homogeneous function in x and y of degree n. Or you can check x is replaced by, that is by considering f of kx comma ky. X is replaced by kx, y is replaced by ky. Simplify, you will get k power n into the given function. Therefore, by Euler's theorem tells that Euler's theorem, comma, x dou f by dou x, that is del f by del x, y del f by del y is equal to n into f over. Or at home you find partial derivative with respect and then multiplied by x. Second step, partial derivative with respect y and then multiply by y. Add these two results, you will get definitely n into given function. That is the beautiness of Euler's theorem. Second example, if u is equal to sine inverse x plus y divided by root x minus root y, comma, find x del u by del x plus y del u by del y. Solution. Now see, here x and y are pre-operated by some function sine inverse. If there is no sine inverse, then degree 1, 1, numerator degree 1, denominator degree, each is of same and equal to half. So total degree, whenever in the form of quotient, you just difference of both numerator and denominator gives the total degree. Okay, that is 1 and this is half. 1 minus half is equal to half whenever this sign inverse is absent. Or you just apply the procedure, x is equal to kx, y is equal to ky, substitute kx, ky, and finally you bring or express this is equal to k power some number, k raised to some number into the given function, then only it is homogeneous function, otherwise it is not. Okay, so here it is not a homogeneous function. U is not a homogeneous function, but just bring sine inverse to left side, that becomes sin u. Sin u is equal to x plus y divided by root x minus root y. So this is called a function of u. Now this left side variables x and y, independent variables, are free of the functions. Okay, now it is a numerator same degree 1, denominator same degree half, so total degree is equal to 1 minus 1 by 2. Homogeneous function is a homogeneous function in x and y of degree, n is equal to numerator 1 minus denominator half. Suppose numerator is x plus y square, then the two terms are of different degree, then this theorem is not applicable. Okay, whenever it is in the quotient form, numerator is of same degree, denominator is of same degree, then the total degree gives numerator degree minus denominator degree. Whenever the terms are in product, add the powers. So this is equal to half. Therefore x del u by del x plus y del u by del y is equal to n into f of u divided by f dash u. That means what is n? Half. Half times fu means sin u. Sin u derivative, that means cos u. So this simplifies to half tan u. But if you calculate by originally partial derivatives finding and then pre-multiply x and y adding, it takes lot of time to get this answer, half tan u. Next definition is total derivative. Let u be a function of x and y, two independent variables x and y. That is, u is equal to f of x comma y, and x comma y are functions of t. That is, x is equal to some phi of t, y is equal to some psi of t. Then u become a function of t alone, and first result du by dt is equal to del u by del x into dx by dt plus del u by del y into dy by dt. Second result, du by dx is equal to del u by del x plus del u by del y into dy by dx. Third result, du is equal to del u by del x into dx plus del u by del y into dy. just highlight this term. I will tell you how to calculate that term. So u is basically a function of two independent variables x and y, and x, y are themselves functions of another single independent variable t. Then if you substitute here in the basic relation, then u becomes a function of t alone. Okay. So instead of substituting, what is the procedure for first finding du by dt? So this is by direct substitution. Okay. Indirect substitution means these are the formulation. Without indirect, not indirect substitution, without substituting that x and y here, how to find du by dt? Now u is basically how many variables? Two variables. So they occur, that is the partial derivative comes the case del u by del x, and other derivative is del u by del y. These are multiplied by, now here it ends at x, just by chain rule this is multiplied by x is in terms of how many variables? Single variable t. So ordinary derivatives comes. So dx by dt, and y is also a function of single variable t. So that's why it is multiplied by dy by dt. Easy to remember. Now this second result is obtained by just in this first result putting t is equal to x. Put t is equal to x, that is du by dx. This is same. Dx cancel. This dy by d becomes t becomes x. So that is dy by dx. I will give you the formula how to find dy by dx. Then third result is obtained by second result, just sending that dx in the left side to the right side. You will get. So this is called is total, that means all derivatives comes here, total derivative of u with respect to t, and this is called, this result is total derivative of u with respect to x, du by dx. And this is just total derivative of u. That is the difference between these three. Depending on the questions, you apply properly one of these 1, 2, 3 results. Please by heart this result. Note, if f of x comma y is equal to c, c is a constant, whether it is a implicit function or explicit function, okay, then dy by dx is equal to minus del f by del x divided by del f by del y. This is the formula for finding dy by dx, which is came in second result. So that whenever a relation between x and y like this given, then this is the formula for finding dy by dx. Substitute there, you will get total derivative of u with respect to x. Example, one example I am going to do, other example I am giving you, later you calculate. Example 1. The total derivative of x square y with respect to x, where x and y are connected by the relation x square plus xy plus y square is equal to 1. Solution. So here the derivative to which quantity we are finding x square y. Let us take that u is equal to x square y. Then what we have to require? Du by dx. Listen this sentence. What I underlined. Total derivative of x square y I have taken u. So that means we require du by dx. What is the formula? Del u by del x plus del u by del y into dy by dx. Let us say equation 1. Now how to find that dy by dx? Let us take the other relation f of x comma y is equal to x square plus xy plus y square minus 1 is equal to 0. So let us denote that 0 as c, or you can place 1 at the other side, that is c is also 1. Then what is the formula for finding dy by dx? Minus del f by del x divided by del f by del y. That is minus, what is with respect to x? Partially this is x square derivative 2x, with respect to x means y constant, so x derivative 1 into y, that is y square derivative constant derivative alone 0, and divided by, with respect to y means x square becomes 0, that means x here constant, y derivative 1, so first term simplifies to x and then y square derivative with respect to y to y. So this is the value of dy by dx. So therefore one simplifies, one implies du by dx. What is del u by del x? U with respect to x means y constant, x square derivative 2x into y, plus del u by del y with respect to y means x square constant, x square into y derivative with respect to y is 1 into dy by dx. Just now I calculated minus of 2x plus y divided by x plus 2y. Depending on the options, simplify further wherever it is necessary. So now I am moving to maximum value. Before that, one small example recently asked based on this model. (2009) the total derivative of x into y is, later you do, okay. Anyhow you check, I am giving the answer x into dy plus y into dx. Later you check this is correct or not according to the previous three total derivative formulas, which result is applicable properly. And in differentiation, sometimes you remember, that means sometimes the questions asked on this, okay. D by dx, derivative with respect to x to mod x, is mod x by x if x not equal to 0. So better to remember this result as formula and chain rule. D by dx of, not chain rule, composite function derivative, f circle g of x is equal to f dash of gx into g dash x, just formula based only, okay. And this result is also denoted by f circle g dash of x. That dash indicates derivative with respect to x. And the third one is, if parametric difference x is equal to f of theta, y is equal to some g of theta, then dy by dx is equal to g dash theta divided by f dash theta. Dash means derivative with respect to theta. That is, whenever x and y are in terms of theta, theta is parameter, parametric differentiation. Similarly, chain rule is, if y is equal to f of z and z is equal to g of x, just a three variables relating like this, then dy by dx, y derivative with respect to x, but y is a function of z, z is a function of x, just like a given total derivative procedure, dy by dz into dz by dz. Just these are one mark formulas, okay. Sometimes the results questions comes like this, directly formulas. Please remember these statements, formulas. And yesterday I gave equation of the tangent and normal also, dz by dz. Just these are one mark formulas, okay. Sometimes the results questions comes like this, directly formulas. Please remember these statements, formulas. And yesterday I gave equation of the tangent and normal also, just remember that formula also. Now I am moving to maximum minima. And uv and u by v also I am giving for some people, those who are lagging in basics. D by dx of u into v, that is v into u dash plus u into v dash. Each dash or prime stands for derivative with respect to x. D by dx of quotient rule, u upon v or u by v, v into u dash minus u into v dash by v square, where denominator not equal to 0. Basic differentiation procedures. The prime or dash stands for derivative with respect to x. Next. So two types of maxima and minima. The first one is absolute, other name is global. Absolute is also called global. Second type is local, which is also called relative. Similarly, minima or minimum. Here also absolute or global, local, another name is relative. So maxima, minima are of two types: absolute, local. Other name for absolute is global, other name for local is relative. Okay, now I am giving the procedure for how to find in each case where these occurs at a time in a problem, or only few of these occurs in a comes in a problem, like that. Okay, see, f is the given function which is defined for every x in the domain. D is called the domain of the function fx. Okay, if f of c greater than or equal to f of x for all x in the given domain of the function, okay, then this f of c is called the absolute maximum, that is the maximum of the given function value, and the corresponding f of c is the maximum value. Okay, then f of x is absolute maximum at x equal to c, and the corresponding f of c is the maximum value. Whenever f of c less than or equal to fx for all x in the given domain, then we say that f of x is absolute minimum at x is equal to c, and the corresponding f of c is the minimum value. Okay, then I will give you the how to find local, that is relative maximum and minimum also. Okay, now if f of c greater than or equal to fx for all x in some open interval containing c, some open interval containing c. You know how to find what is the meaning of open interval. Whenever an open interval containing c, in that is called domain of that function, that open interval is taken to be domain of the function, every x satisfying this relation, then f of x has local maximum at c at x is equal to c, and f of c is the local maximum value. Similarly, f of c less than or equal to f of x for all x the same, some open interval containing c, then f of x has local minimum at x is equal to c, and the corresponding f of c is the local minimum value. So for the given domain, for every x calculating the f of c value takes a lot of time. So there is a procedure for finding maxima, minima, absolute maxima, minima, etc. like that. Okay, generally there are two types. Suppose a function is given, how to find maxima, minima for one variable and two variable functions. Similarly, if a function is given in closed interval a comma b, closed interval 1 comma 2, like that, in that case which type of maxima, minima, that is the name of the maxima, minima, like. So I will give you the procedures. There are three types of models in maxima, minima. I am going to do each one of, that means one by one each. Procedure for finding maximum as well as minimum or both for a function of x, one variable function, for a function of one variable, say x, that is f of x. Procedure for finding maxima, minima for one variable function fx. 1. Write stepwise. Find f dash x. Step 2. Solve f dash x equal to 0. Let x is equal to a1, a2, a3, so on, be the stationary points Let us say this is equation 1. F dash x equal to 0, the equation is 1 with the stationary points obtained in 1. Step 3. Find f double dash x at x is equal to a1, a2, etc. Find the second derivative. Step 4. At x is equal to a1, comma, first condition, if f double dash x less than 0, then f of x is maximum at x is equal to a1. 2. If f double dash x greater than 0, then f of x is minimum at x is equal to a1. Step 3. In that step 4, third point, if f double dash x equal to 0, comma, find f triple dash x. Full stop. If f triple dash x not equal to 0, then f of x is neither maximum nor minimum at x is equal to a1. That is, x is equal to a1 is called a point of inflection. If f third derivative 0, comma, find f fourth derivative x and f fifth derivative x, find f fourth derivative x, etc. and apply 1, 2 in step 4. Repeat the step 4 at x is equal to a2, a3, so on. Let me explain. Just here I am writing a note point. If a curve crosses the tangent at a point P, then P is called point of inflection. Just see. This is the rough example of graph of y is equal to x cube graph, rough example. At 0, if that is the tangent crosses the curve crosses the tangent, that is x-axis at itself. That is, at 0 we cannot say that is it is maximum or minimum. whenever a curve crosses the tangent at a point P itself, then P is called point of inflection. That is neither maximum nor minimum, point of inflection. This is the geometrically a graph of y is equal to x cube has a point of inflection at 0. Or take this fx is equal to x cube. Using this procedure, you will get third derivative not equal to 0. This is the mathematical procedure without graph, saying the point is point of inflection. Okay. Now, step 1, find first derivative and equate to 0, say equation 1. Solve this equation. You will get some x values denoted by a1, a2, a3. These are called stationary points. Stationary points means maybe maximum, minimum, or neither maximum nor minimum. Okay. Step 3, find second derivative at each point. Step 4, take first point a1. Calculate, substitute this a1 in the second derivative. If second derivative less than 0, then fx has maximum at x is equal to a1. Second derivative greater than 0, then f has minimum at x equal to a1. If second derivative is equal to 0, then find third derivative. If third derivative not equal to 0 at x is equal to a1, then that point is called point of inflection. That is fx has neither maximum nor minimum at x equal to a1. If third derivative equal to 0, then find f fourth derivative, etc. That is, repeat the above process 1, 2 in step 4. Apply 1, 2. 1, 2 means in step 4. That is, even order derivatives you have to show less than 0, greater than 0. Odd order derivatives you show equal to 0. Odd order means f dash, f triple dash, etc. Even order derivative means second derivative, fourth derivative, etc. Whenever you need fourth derivative, fifth derivative, sixth derivative, etc. like that. Repeat the step 4. This step 4 for other points a2, a3, so on. This is the procedure. Please by heart. So this is one example rough sketch of a graph fx is equal to x cube, y is equal to x cube, where the curve crosses the tangent at x equal to 0. So x is equal to 0 is a point of inflection, that is neither maximum nor minimum. Or you can verify by this procedure after finding third derivative and showing that third derivative not equal to 0. And minimum maximum are also called extreme points. Okay, the points where the function is minimum or maximum or both, that points are called extreme points, and the corresponding fx values are called extreme values. Please remember, stationary values, stationary points, extreme values, extreme points. Stationary points, these are when you substitute these one by one point in the given function fx, the corresponding f values are called stationary values. Okay. Now maximum, minimum values are also called extreme values. Okay. Whenever at a point x is equal to a1 or a2, the function is going to maximum or minimum. Okay. That points are called extreme points, and the corresponding f values are called extreme values. Extreme values means either maximum or minimum or both. Okay. One example I am going to do. See, instead of x variable, it may be given any y variable also. Any variable, one variable function. Just I am going to do one example. First problem. This is given 2010, 2 marks. If exponential y is equal to x raised to 1 upon x, that is x to the power 1 by x, then y has, option C, y has a maximum at x is equal to e, b, minimum at x is equal to e, option C, maximum at x is equal to e raised to minus 1, d, minimum at x is equal to e raised to minus 1, that is e power minus 1. So all of you please remember the procedure.